Okay, this is about velocity, changing velocity. Okay, the delta means change, v is velocity, and we're going to be doing x t graphs or position time graphs, and vt graphs or velocity time graphs. All right. So first of all, this is my object here, and if the object is speeding up, you'll see that the space between the dots is increasing. Let's say each dot is at a specific time interval. Okay, so maybe 1 second has passed between the dots, and you'll notice that more distance is being covered. So in order to graph that, I end up drawing a curve for my position time graph because the space between the dots is increasing for each dot. Okay, for each unit of time, and in order to graph that, I have to show a curve here. All right, and what you'll see here is that the change in position over the divided by the change in time is getting greater and greater and greater as time goes by. Okay, here change in position for your change of time is getting greater and greater as time goes by. My velocity time graph is going to be a slope. Okay, it's not going to be a flat line anymore like up here. Okay, it's just a slope, and the slope of this line is velocity divided by time, and the slope is meters per second divided by seconds. Meters per second divided by seconds is acceleration. So the slope of my line here is actually my acceleration. And what I showed here at the end is I wanted to compare an object that isn't moving, moving at a constant velocity, to an object that's accelerating. So in order to show that this object is moving at a constant velocity, now I'm just gonna it's gonna have a flat line like that, okay, or a straight slope like that. Yeah, that is velocity time graphs and position time graphs for a changing velocity.